One useful technique in systems engineering is functional decomposition. Now, functional decomposition is when you turn a system into a smaller set of systems based on its functions. And so what is a function? We talked about how for requirements, you derive a bunch of sub-requirements based on a main requirement. Functions work essentially the same way. Your system is going to be designed to perform a specific function. For example, if you have a coffee machine, well, what is that supposed to do? It's supposed to brew coffee. Brewing coffee is the function of the coffee machine. It's the main one. But in order to brew coffee, you have to do a few other things to make that happen. And so we would call these sub-functions, derived functions. And so in the case of a coffee machine, it might be heating water or saturating coffee beans. If you're going to be a little bit more of an actual systems engineer, sometimes I've seen people derive them with the gerund form of a verb plus a noun. And so that's the form of a verb that has the ing on the end, like running, swimming. So brewing, sustaining, rotating. So you say brewing coffee, sustaining lift, if it's like an airplane wing, or a drive shaft. One function of a drive shaft would be rotating a wheel. And when you derive subfunctions from these functions, you really keep doing this until you can't anymore, until it quits being rational. And the more and more granularity that you do this with, and the more levels of functionality that you define, the more detailed your system design is. You can decide, of course, when the stopping point is where you feel happy and ready to start implementing and designing around these functions and groupings. But generally, more is better because it really forces you to think about what it is that you're doing. An alternative to functional decomposition is object process methodology called OPM. This is actually an ISO standard. It's so widely used in systems engineering that it got its own standard. And it's a very formal design language for describing system components and functions. And everything in OPM is either an object or a process. And this isn't something we're going to use in this course. It's really it's a bit heavy for individual projects and less formal projects, but it's something to be aware of because you might see it if you happen to work with somebody who is a formally trained systems engineer. So it's just worth being aware of. So once you have developed all of your system functions, you can use them to help plan implementation. So sometimes it's useful to start grouping functions together, maybe even draw a diagram and start putting things in different circles and start to conceive what functions might belong to what parts of a system. And in this way, you can develop some subsystems. And each subsystem might be responsible for a different set of functions. And just a reminder, this is not making implementation decisions. It's not the same thing as picking out a specific component to perform a function. It should be really higher level than that. That's still engineering work. But it may, help you further refine the system design and think about how you might want to split up work or what kind of project you really have ahead of you. So once you've started grouping functions together and conceived of subsystems that you need to implement, then you can create what's called a block diagram. And a block diagram is exactly what it sounds like. It's a diagram in which the entire system is represented as a set of blocks. Some blocks are within other blocks, and that means that they're subsystems of the block that they're in. So every block is essentially a system. In this example, I have the car here as the biggest block. And for those who aren't familiar with cars, a lot of them have something called a CAN bus, and it's just a specific kind of communications link between different parts of the car. And it's really common in block diagrams to have different arrows between subsystems showing where data is flowing. Sometimes if they're one-sided, that means data is flowing from one system into another exclusively. Here, we got everything bidirectional. And each one of these blocks is a different subsystem. And notice how there aren't any details inside of them. And that's because at this level of detail, each of them is what's called a black box. And a black box is a term in engineering where we don't care what's going on inside. We only care what the system is taking in and what the system is giving to us on the other side. As long as we can give it the correct inputs and receive the correct outputs, we really don't need to know how it's creating those outputs. And so you'll see this come up a lot. You'll hear this term. It's also really useful for thinking through your system design. Again, you might consider the coffee machine. What are the inputs? Okay, you need electricity probably. You need water to brew the coffee, beans, etc. And every time that you go through some sort of rigorous framework like this, you're exposing flaws in your design and rethinking them and making it better. So let's review. Functional decomposition refines the desired functionality of a product. Object process methodology is a sophisticated technique to define a system in terms of objects and processes. Both systems engineering techniques are useful for planning implementation. A system can be represented as a block diagram. A black box is a model of a system in terms of its inputs and outputs. And this was a absolute speed run of these concepts and a really informal rendition of them. I'm sure that if any actual systems engineer is watching this video, they will have about a million objections. But if you are working on a personal project or a project on a small team, or even at a company without formally defined processes, this is plenty to get you across the finish line. You can run through these exercises and start work.